what we'll be discussing today are two different methods to approach the field of agriculture. We call these proactive and reactive, and the idea is that when you are deciding the planning of an agricultural scheme for a nation or for the world, you can think of whether you want to prevent diseases from happening in crops or whether you want to be able to react quickly. Hardly you are able to do both. Because if you invest a lot in preventing things from happening, then you will probably have slower reactions because you don't expect diseases to actually appear. On the other hand, if you have a variety of reactions ready, hardly ever you're going to be able to prevent everything from happening, so you will lose something. Do you see the trade-off in here? Somewhat? Okay, so hopefully the teams will be able to shed a bit of more light on this, but what I would like you as the audience to focus on is do not obsess too much on the agricultural point. But you should be trying to reflect on what is the role of technology. So when we're looking at agri-tech, we're looking at technology that serves the needs of humanity in the most basic functions, giving us food. Okay? So your role as the audience today will be to try to establish how do we make sure that this is done well? How do we make sure that this is done to create a planet where we want to live? Okay? So, regardless of what presentations they will give, try to push them to understand what their vision is, to understand why they think their view of technology serves the idea of making a better world for everybody. Okay? So don't be afraid of giving abstract questions, but push them. All right, so I think they already set up their computer, so they have the right to start.
So
they were very proactive in this.
15 minutes.
Yeah. So hi guys, hi everyone. I'm Alessandro. We are the group B, and as you can see, our goal is to make all of you understand why in agriculture, or in general, a proactive approach is usually more efficient, more healthy, and in general it's better. So, before we start, as Leonardo said, I want to make a point of this battle, because it's a little bit different with respect to all the previous ones. Because here, it's somehow hard to find information and stuff like that. Moreover, the a priori knowledge that everyone has, I've also seen it by talking with you, was quite low. So I did just some basic definition about what a proactive and a reactive system is in general. All right. So, given a system that could be a mechanical system, an electronic system, an economic system, or an agricultural system that varies with time, we know that a problem may arise. And with them, we need to deal in some method. So how do we do this? Well, we have basically two ways to do it: a proactive way and a reactive way. By definition, if we say that a problem with a given probability may arise here, everything is then done before the problem arises. So, in order to prevent it from happening, or in general to reduce its magnitude, is called proactive, which is preventing basically. From the other side, everything is then done after is called reactive, because you're reacting to the problem. It's the classical way of seeing of prevention, the cure. This is an old sentence, but now all this can sound a little bit hard, a little bit weird. So let's make an example of our everyday life. Here, as you can see, this is a classical example of a preventive or a proactive approach against a reactive one. Here, we are dealing with the problem, the carrots in this example, before it actually appears. And here, we are dealing with it after it's appeared. So, as you can see here, we are, just in this example, we are saving for sure money, for sure pain, and we don't have to take an appointment with that bad guy. Now, this is an extremely simple, extremely easy example taken from WikiHow. But how do we move all those concepts to agriculture? Well, let's see. I'll make a brief introduction on the history of massive agriculture. So I start from the 1930s, and I get to the start of a proactive approach in agriculture. So this is the basic scheme of acting, a little bit simplified, but that's the basic of a reactive approach. Basically, you watch if there is a problem. If there is not, you do nothing. If there is a problem, then you act. First time this logic was used, it was in 1939 in the United States, where DDT, an extremely powerful and very efficient pesticide, was developed. Actually, it was developed by Switzerland, but it was only used in the United States. Well, it was perfect because it removed weeds. It was terrible for fungus and pests, and moreover kills a lot of insects. So it didn't cost that much. It was extremely easy to produce, 10 out of 10. And indeed, it did work for 20, 30 years until someone found out that it was highly cancerogenous. And moreover, what it did, it brought some allergies and intolerances to people who actually lived near a field where it was used. So in 1972 and in Europe in 1978, it was completely banished from the market. So farmers said, yes, but we need something else. And indeed, other approaches have been found, working with a reactive approach still. So basically, they used a lot more substances for get the same result. And well, that's how it worked until the 90s. You know, it was the 70s, the 80s. People didn't bother that much about environmental stuff. So yes, then in the 90s, with the first discussion on greenhouse effect and stuff like that, people started to say, but wait, can't we somehow reduce the amount of products that we are actually using after to deal with the problem in agriculture? Well, someone said, what if we just take the problem in its first stages, when its first phases, when it's still weak, then we attack it when at its beginning. So we just need a little bit of pesticides just to have the same exact effect. So in other way, the basic concept is to attack the problem when it's weak with way less pesticides than when it's grown up and is strong, which requires tons of pesticides. Well, this is called proactive approach. It's basically almost found on all based on a probabilistic approach. So it basically says, all right, I have my data acquisition and elaboration. It can be some wireless sensor in your field that measures motion and temperature or humidity percentage, which could lead to some probability of disease. It could be a bad insect, a disease, a fungus that happen, and you then say, all right, I have this probability of this disease to happen. How do I deal with it? And here you can regulate exactly the quantity of products that you need to use to completely remove it. Now, this quantity is way lower than than the one used in the reactive approach for getting the same results. Indeed, I'm not the only one who says that, but also European Union tries to say it because they say, wow, but pesticides, they don't only damage people from a point of view of health, but they also damage the environment because they go into the soil, they go in the river, in the water, and then, to the fish, it's in the air that we breathe. So we need to remove them the most we can. And given that a proactive approach mathematically reduce the use of them, basically what the European Commission said is that preference should be given to application of preventive measures in pesticides and control, which is actually the basic definition of proactive effect or proactive approach in agriculture. Now I'm leaving the stage to my colleague Matteo, which will give you some example.
Okay, here we see 3 examples of a proactive approach and why it's better than a reactive approach. The first is the seed treatment. Near every farmer in the world use seed treatment. The seed treatment is consists in hydrate the seed with some substance like insecticide or fungicide in a very small quantity. And this prevent the disease to came on the latest stage of life of the plants. If we instead apply a reactive approach, there is also the risk, the first, of death of the seed. So when you plant your seed, they don't create a new plant. And first, they can develop some diseases that are dangerous for human life, like the ergots, or like in these photos. The second big problem the farmer have, and that require a proactive approach, is the fungi. The fungus are one of the major cases of troubles in Europe, because they grow very, very rapidly, and especially they are the example, some fungus are cancerogenous, and when they start, a lot of times the unrecoverable points is below when they can detectable by instrument or by the humans. And an example of this is the corn aflatoxin. They destroy a lot of fields in Italy, because when it's detected by law, it needs to be sent as biogas, as biomass. So. And new technology in this case can help. In fact, normally fungus grow very, very quickly if they have the current environment conditions. So high humidity or high temperature too. So the wireless sensor networks can help to manage what is really the humidity of the soil, and manage the connected dry plants. The last case is with the biochemical, or more in general, there is a new research field, but in reality it's a practical things, where we use to combat disease natural instrument. An example, we have a rice fungus, that is the Pircularia grisea. It's a fungus with it's a fungus that destroy or reduce a lot the yield, about 80 or 90%, and instead of apply other type of instrument, we research found that the extract of the bamboo oil can, if applied before the fungus present, can avoid the presentation of the fungus, especially if in the previous years the fungus show on the same fields. I want to close these things with a couple of questions that I have, and first is if a proactive approach is very true that is more helpful. In reality, the study showed that using a proactive approach spray less chemical substance on traditional fields, so without applying natural technique, less substance, around 10% or more, depends what approach you choose. And normally they are applied before, so the plants have more time to absorb this substance. The last question is about the GMO. GMO in reality is effectively a proactive approach, but we discovered that the GMO in most cases is made to make the plants resistant to some toxic product used in a reactive approach. These include, for example, the glyphosate or the herbicide or pesticide using after, so they don't destroy also the good plant. Thank you for your attention. Here you can see the reference we use, and if you have any questions.
So very on time, you saved some minutes. So next presentation.
Come si fa lo switch del...
Lo puoi buttare fuori da qua.
Esatto. Forse prima era attaccato sul precisione. Ok, va bene, PC1.
Basta che strucchi il botto qua.
PC1. Ah, fantastico, perfetto.
Minutes also for you, when you want.
Okay.
Okay.
Hi everybody, my name is Davide and today I will show you the reason why a reactive approach to disease management in agriculture is the best solution. Let's start with the main question of the day. Why a reactive approach and not a proactive approach like them? The first reason is caches, because a proactive approach is very costly, very expensive. You really need big money in order to build up a fully proactive system. The reason here is here explained because disease prevention constantly creates new diseases to prevent. And this is nature, because in nature each kind of organisms such as bacteria, pathogens, insects tends to evolve in order to overcome host defensive system. So in a proactive system you have every year to research and produce new antibiotics and new pesticides in order to defeat these new attacks. And this is a vicious circle, and this is extremely expensive. On the other hand, the cost of monitoring our plants and the cost related to the application of the countermeasures to a disease is in constant reduce, because thanks to the fact that ICT solutions are not so expensive. So, for example, if you apply chemical solution for prevention to your plants, as you can see in this graph, the cost of the overall cost is linear with respect to disease severity. Instead, if you use ecological solutions in order to also improve your plant health, your cost is relatively stable, and you have less impact to the environment. Moreover, typically a common farmer will choose the solution that has lower cost and at the same time higher economic returns. So typically a farmer will choose our reactive system because it has less costs and higher returns. And he will not choose their proactive system because it has higher costs and less returns. Now let's talk a bit about environmental sustainability, because a proactive system is studied to prevent a small subset of illness. But what about if a new illness, for example, a new insect or an evolved bacteria, will attack your plants next year, and you haven't done any research in order to defeat that problem? Their practice system is completely lost, because they lost all. Instead, in our proactive system, in our reactive system, we have to be prepared to this kind of attack. For example, European Space Agency permits us to access real-time satellite images for free. So, for example, we can use those images to prevent those kind of attacks for free, for example. Now let's look to the climate change, because it is nowadays a real problem. So global warming and climate change nowadays are triggering big changes in geographical distribution and population dynamics. So how a proactive system can also be prepared to defeat these big changes? So again, they need a lot of money in research in order to defeat this kind of fast changes. Again, we only need, for example, satellite images. For example, to see if a new insect is migrating in our country. Moreover, a report shows that about the 30% of the overall emissions that leads to climate change are produced by agricultural activities, including the pesticide usage. So, in our reactive system, we use pesticides only if a plant presents a disease, and this disease overcomes a certain threshold. Otherwise, we don't use pesticides. Instead, they always use pesticides in order to prevent any kind of possible disease. This leads us to talk about biodiversity, because pesticides destroy biodiversity. For example, pesticides can have short-term toxic effects on directly exposed organisms, but also there can be long-term effects that brings big changes in habitats and also in the food chain. So, in their proactive approach, they are destroying our biodiversity, and at the same time they are causing global warming. Now Christian will talk about the technology involved in this field.
Thank you. So, hi guys, I'm Christian. As my colleague said, now it's time to talk a bit about technologies, but before going deep into details, let me explain you how the main parts of our reactive disease management systems are. So, I hope you are still awake, because I really think it's an interesting part. So, as you can see from the slide, of course, first of all, you need to detect the problem through a constant monitoring. After that, we have to know who we are fighting, and finally, we have to apply the correct cure in order to counteract the problem and avoid the spreading inside the field. So, I put it on the slide some example of technologies that can be used for the detection. So now, how many of you are familiar with at least one of these technologies? Please raise your hands. Okay, so I will not spend so much time in this. So for example, with drones and remote sensing, you can get RGB and multispectral images in order to know if there is a problem before any visible sign to human eyes shows. But of course, you can use also wireless sensor networks for constant monitoring the health state of the plants, and This is a very interesting technology, at least for me, because I like electromagnetic fields. Because with open-ended coaxial probes, you can do dielectric characterization of the plant, and you can detect if there is a problem in an electrical way. Now let's move to the localization. Of course, you can use computer vision or other image processing tools. And finally, I put it an example which comes from nanotechnologies, because through autonomous nanosensors, which are linked via a GPS system, you can collect data like a wireless sensor network, but in a more precise way in order to counteract more precise the problem. Okay, now let's move to the diagnosis. Of course, you can use a neural network or other machine learning tools in order to find the disease, but if it is not sufficient, you can also do some lab analysis. For example, you take a leaf, go into a lab and do some chemical analysis and find the correct diagnosis. Again, if these two things are not enough, you can also ask to an expert, like the one I put it on the slide, and he can help to find in a more precise way the solution. Finally, of course, you have to cure the disease. And again, there are a lot of possibilities nowadays. I put it some interesting ones, which are also ecologically friendly, which are not pesticides. So the first two comes from nanotechnologies. With nanosilver, you can stop several types of diseases and unwanted microorganisms. Nowadays, it is used as a foliar spray to stop fungi, moults, which in Italian means muffe, and rot, which again in Italian stands for decomposizione. And another interesting one is the use of magnetic nanoparticles, which you can apply in your field in order to protect the other crops which are safe from the treatment that you are applying. Of course, you can also use traditional treatments like eradication, pruning, or isolation. But of course, you can also use agronomic and biotech methods. Now, just to show that what I'm telling you are not jokes or fantascience, I pick an example of an application which is not so expensive, so can be used for also by small farmers. With Sailog, which as you can see is an artificial intelligence-based solution that enables farmers to identify and treat several hundreds of diseases and pests. So it's a very good solution. I would like to remark a thing. 30 years ago, there was not all this ICT technology, and so reactive systems were not so effective. But today we have the possibility to change our way to make agriculture. So now I leave my colleague Matteo to talk a bit about health issues.
Good afternoon, everybody. So I would like to bring to you an example of a very real problem that is not discussed enough. And it's a problem brought about by the use of pesticides and antibiotics in agriculture. What happens is the large use of antibiotics changes the environment in which bacteria live and forces them to evolve to be immune to those pesticides. The immunity in bacteria can be shared between different species and can easily spread. And it creates what are called superbugs, or in more scientific terms, it's antimicrobial resistant bacteria. They are bacteria which have many resistance to most of the usual antibiotics. They can travel from your food to your body and infect you with very, very dangerous diseases. And they are dangerous because they are almost impossible to treat, since these bacteria have evolved to be immune to almost all antibacteria. So just to give you a few figures, a review from the British national government found that nowadays more than 700,000 human deaths are related to these antimicrobial resistant bugs. And they have estimated that by 2050 the number will grow up to 10 million people dead per year. And in the next 30 years this will cost the world $100 trillion in general losses related to health and to food losses. So this is it. Thank you for the attention. And if you have any questions.
Okay, we also save some time.
Thank you. So while you're setting up for the discussion, I would just draw. Can I shut this off? Do you mind?
Yes.
Also to just the lights. I would draw your attention to one thing. So they both have discussed a number of things. I think that usually you start from question from the audience, but I would like for you to focus on two things. First, try to challenge the conventional wisdom, because both of these positions rely on some preconceived ideas that we have about how systems should react and how they should move, and common sayings that we use also in our language. So when you're thinking about questions to give, try to take one of these common sayings, one of these common questions, and frame it into something where you can probe them to go deeper, to see if this common sense still holds or the common sense changed, as we were discussing also in one of the lectures last week. And the other thing is this, and I say this especially to the teams, don't try to play the blame game, okay? So as much as possible, I try to encourage you not to discuss and not to fight about who is using more pesticides. Try to argue on the impacts and try to argue on the mindset about why things are being done in a certain way, okay? All right, so I think questions now.
Actually, I have a question, but it's very related on this pesticide because they put it on the slides and everything. So you said that just a second, I find that 30% of the CO2 from produced worldwide comes from agriculture, and some of this from the pesticide. But you said that you only use them when needed, and the proactive approach use them more. Do you have like data, like percentages or something, to understand if they use more?
Okay, it's a little bit complicated because there is a, for example, here in Trentino there is the Protocollo d'Intesa Trentino, for agriculture of Trentino, and you have the threshold in which you cannot use any treatment, and if the disease overcomes this threshold, you can use the treatment, but you have a threshold on the treatment use, so you are bounded by this one. While in the other case, you have to treat all the seeds, for example, we said before, and so in this case, you have only to use the treatment in specific cases, and you are even bounded on the use of the treatment. This answer works for you?
Yeah.
Please, one question here.
Yeah, it goes to the reactive approach method. You know, we have some crops that rodents are able to destroy. So if you are using a reactive approach, maybe the rodents are many in that area, and you know there are rodents around. Instead of putting a preventive measure that rodents don't enter your farm and destroy the crops, you wait for them to react before you start putting in preventive measures. And in that case, before you think of approaching that, they might have destroyed a lot of crops. So what do you think about your approach when you know that you are supposed to put this preventive measure in the first place before they even attack?
Okay, so thank you. If I can try to rephrase this question to make it more fitting to the topic, the question would be this. Of course, I would just say it's not their task to deny any proactive measures as much as it's not their task to deny any reactive measures. Okay? They're just talking about the matter of priority. But the question which remains for you, which I think is aligned to this, is the following. Why do you think that now we are in a position where you can react more quickly? How can you be sure that nowadays, if a problem is obviously there, you are able to react effectively without losing what is already there?
So, as I said before, if you remember, I put in an example of remote sensing, wireless sensor network, multispectral images. So in that case, you can detect the problem in the early stage. The problem is there, but you can detect in the early stage. And for example, you can isolate or eradicate the plant which is sick. And so you avoid the spreading of the problem, avoid the rest of your field. You save the remaining crops.
I think his question was more interesting, however, because he was asking you, you're talking about the micro perspective.
Yeah.
He was going from a macro perspective because he was talking about rodents. So he was talking about bigger things. So I think in his question is really, how do you approach this also from when, not about small pests, but about...
May I clarify maybe what reactive versus proactive means? So for us, reactive is not only reacting to the damage and to the problem at its final stage, but it also, for example, if we talk about rodents, putting up a monitoring system to see where they are, how many they are, and reacting to a change of, for example, their location to take the right action. Or a change to...
So, okay, so I think...
No, proactive means you act and then you look what happens.
So everything you do before the damage happens is proactive.
Yes.
So if you start to put in some sensor to monitor, that's proactive by definition. I mean,
okay.
Without...
No.
You're talking about prevention. Our method is to react when the problem is coming.
If you are monitoring something...
Just Google it, proactive usually goes with prevention, and reactive usually goes with curing. That's by definition. Google it if you don't believe me. You find it true. I guess it's more or less the only thing.
If you are monitoring something and you take an action because you see a change, then you are reacting to that change.
Well, no, because if you see a change on temperature, if you see a change of humidity, the damage maybe the fungus maybe still has to spread. The damage is not done yet. Then you are preventing it. You are making a proactive approach. Easy. Nothing else to say.
Sorry, can I add something on that?
Wait, yes, may I have something?
Oh, yeah.
Can I suggest one thing? Stand up when you're talking, okay?
I
hate the fact you have this table here. For me, I would toss away the table and the chairs. Stand up when you're talking.
Yeah. I'd also like to add that I would be extremely interested in see why you say that, I don't remember who said that the proactive usually takes more pesticides, because it's not true. That's exactly what the European Union thing said, I guess. Moreover, it's full of examples where only proactive can be used, like for crop fields, where a reactive cannot do anything, because if you don't spread it earlier, then all the field or the harvest is lost, completely lost. And wait, I'd like to ask, it's also true that probably it may happen that we spread the substance also when maybe the problem wouldn't arise, but on average, we don't use that much as of you. We use, yes, more times, but on average, way less. That's the basic of proactive. That's because it costs less.
Okay, sorry, just one thing.
Can I add a thing about these arguments? Because we see there is WASA in America. It's like a university for farmers, and they make a specific research about these things. So what's a proactive approach? Use more versus a reactive approach, use more or less pesticides. In reality, this shows that using a proactive approach, use 10% or less or more or less using a proactive approach.
Okay, so thank you. I would just point out two things for the sake of the relevance of the debate. 2 points of process for both teams. First, don't argue too much on semantics, because I think that the definitions by now are very clear, and I think they did a very good job at explaining this. Acting before the problem, proactive; acting after the problem, reactive. So please don't go deeper into this, because it's a pointless discussion. Second thing, which is a pointless discussion to me, is a thing about data. So neither of you, to me, have sufficiently convincing data, and you don't have the qualifications to talk about data. So I suggest that you stick to the impacts from a point of view that you have already outlined: social, ecological, health. So focus on impacts. Okay?
Georgiana, you wanted to add something on this?
Yeah.
No. Yes or no?
Yeah, but I just lost the point.
Okay.
So.
Oh, okay. So we listen to this.
I think I have another question.
Another question. Can you stand, please? Thank you.
With the proactive approach, you know there are some pesticides that are resistant to this kind of chemicals. You apply them today, you think they are all gone, but later they grow a resisting mechanism, which later they develop to begin destroying. You realize that you try preventing them in the initial stage, but they grew up becoming stronger, and now no amount of chemical you apply on them destroys their disease. And don't you know that is going to actually affect later applying more chemicals? So some of these chemicals might be washed into river bodies and water, which some people might use as irrigation farming. Don't you think it's going to cause ecological problems to the society?
So, if I can try to summarize, but please correct me if I'm wrong. You're talking about the idea of evolution and resistance in some sense.
Yes.
So you're saying, yes, you are using a smaller amounts of these elements, but this is creating resistance. It's building up resistance.
Yes.
So, this is a point for both teams. I would ask you this: how do you break? Because both approaches have a historical context. Okay, in the sense that a more proactive approach has been what has started after industrialization, especially, while the reactive approach has been the traditional one. However, his question leads you to a point which I think is also good to answer from their perspective, which is, how do you make sure that in your approach we do not repeat the mistakes of the past? So how do you think, for you in practice, a proactive approach can break this induction fallacy related to creating resistance? And on your side, how can you convince us that when disasters happen, the recovery time will be quicker? Okay? Please.
Okay, there is, for answer your questions, actually also the proactive, but I think also the reactive, start to move to different methodology. An example, especially in organic, there is started to be switching to natural methods. Like an example, it's not for related, but for remove or limiting the weeds problem that normally is resolved, an example, with the glyphosate. So it's a potential pesticides, reactive pesticides. Instead, we still try to use cover crop that also have the benefit to prevent the erosion of the soil and to fertilize the terrains. And this crop after became a protection for the seeds, and also because they are like they cover completely the terrains. The plants, the good plants can go through. Instead, the weeds are suffocated by these cover crops, and this and permitting. But there is a series of other systems that's most naturally systems, like for insect. Normally on the organic agricultures we try to introduce, we know what the disease the year before is, and normally we try to introduce natural predator of this insect, so frog, for examples, depending on what is the insect, what is the damage, and obviously with this system we reduce the impact of the using the chemicals.
So, if I can try to summarize your points, and I'm doing this not to favor any team, I'm doing this because you're making interventions, but you are also learning how to speak and how to present. So I try to summarize your points to show you how they can be condensed in a different way. So what you're saying is, proactive measures are not just a matter of applying chemicals. In the latest years, we have acquired ecological knowledge, which allows us to do proactive measures, which are not chemical. And they can take an ecological view to address problems and to prevent them. Is this your point?
Yes.
Okay. Are you satisfied with this answer?
Yeah.
Okay. Can you also make
Yes,
a point?
to answer your question, how do we avoid previous mistakes? So the last time, as they said, reactive measures were used was in the 30s. And the main problem was that we had no technology to have an early sign of diseases. So the reactive measures were applied very late. So what will happen now if we use a reactive approach is that new technologies allow us to see the problem much earlier and have less intervention needed for a full cure.
Okay, so your argument is that the technological development did two things to improve reactive measures. First, it reduced the detection time, and second, it made for reactive measures to be more accurate. So you cause less collateral damage.
Yeah, and
Okay.
also if I can add, not only more accurate, but also better for the environment. For example, we brought nanosilvers and a lot of nanotechnologies that can be used in a reactive way are not impacting on the environment as pesticides were.
Okay, thank you. Do we have more questions from the audience?
If I have some,
Can us wait just a second? Can we have more voices just for, and then we will come back to you.
If there
it's,
are,
it's just related to the same thing. That's
Okay,
why I was
okay.
What's
if
the
it's
question?
related, please go. You can stand.
Taking for instance introduction of predatory animals into the farm. How do you know that, okay, in the next few months I'm going to have locusts in my farm, I'm going to have this in my farm, for you to introduce those predatory animals in the initial stage? Because it is you seeing the problem, that's when you begin introducing those kind of predatory animals to kill them. So with your approach now, I don't know how you foresee that those animals are going to be in the system.
Okay, thank you. Let me try to reframe this once again. The point would be this: how do you make sure that your proactive measures are going to be the ones that are actually needed? And what happens if you apply a proactive measure which is unneeded because you risk of causing collateral damage because you applied a proactive measure that then ended up being useless?
While you think about, I would like to ask you, are you intention to have an entrepreneurial idea on agriculture? You want to open a business, we can discuss later on. Please.
Normally there is we also use the satellite image, and more or less we know from an example, normally the aflatoxin I speak before, they start in America the year on the 2015 and arrive here in Europe in 2016. So if we normally when you do the example organic farming, you have the certifiers or the account manager that suggest you and watch this data for you if you are a farmer. And with this data you can be near sure that what the predictor you insert in the nature work, but because normally, because if this predator is inserted in nature and this for disease or this insect don't show up, normally this predator did for starvations because they don't have food.
Sorry, I have to say I was not fully able to capture your point. No, I'm not trying to criticize, but
No.
could you try to summarize it very crisply?
Okay. When you normally when you introduce a natural predator inside your environment, you are pretty sure that the predator have enough foods based on data that you have.
Okay. Thank you. So your point is we have reached a point in which these techniques are sufficiently well developed so that this does not happen. This is what you're saying. So it does not happen that you are applying preventive. When we're going for this ecological prevention route, we are by now our models are good enough that this doesn't apply. This isn't applied randomly. This isn't applied needlessly. Okay.
For me, add something. Usually, all those things are before that made on the actual field are tested in lab on a micro scale just to see how they work, and then are obviously applied on the macro field. I mean,
Yes.
I did before. I assume that you know it for sure, but let's make sure.
Okay, thank you. More questions from the audience. I encourage both teams to also let other people speak, because so far we're just seeing mostly 2 and 2 people. Okay? More questions from the audience? Yeah, new voice.
The proactive, I don't know much about the techniques you have, like proactive techniques. Are they applicable to every region? Because every region has a different temperature. Like in Australia, it may go very hot, or some other countries. So, whatever you have tested, or you suggest some technique, is it applicable all over the world?
Okay, thank you. I try to recontextualize this question and add one more thing. So, we live in a world which is increasingly globalized, okay? So, what you have to trade off are 2 things. First, to have proactive measures which are generalized enough that they can be applied in multiple spaces. Otherwise, you risk of spending a lot of time and a lot of resources to just get a solution that works in one field. Okay? So how do you address this? I add an appendix. No, actually, I'll let you answer this. Yeah.
All right. But basically what is done, since the end of the story, data that we need to prevent...
Sorry, can we have another person? Try to... If you're fine, otherwise you can go. Sorry.
I can answer.
Yeah, please.
Go.
So the thing...
Stand up.
Yeah, of course. So the thing is this. You said in all world we can have a different kind of diseases, different kind of plants, and of course that's true. But I mean, every country and every culture can develop his kind of proactive methods. Of course, basing of the history of that place. And so, if there are strong companies that develop this kind of products to prevent diseases and things like that, of course, they are based on a study and history of that kind of place. This in general.
Okay, thank you. Are you satisfied with the answer?
Because in reactive approach, we can use all over the world. Because after seeing that thing happen, we just apply that technique. But in proactive technique, what you said, we have to study in each places. But there are some countries where they don't have much money to do research and all these things. That's why I asked.
Yeah, of course. But nowadays, if you think, we have also the laboratory to do tests, but also the history, because every disease, every problem that we have in general in nature is kind of recorded and studied. So there is not this kind of this problem in general.
Okay, thank you. I will add one point, and this was my follow-up to this. Since we are in a world which is increasingly globalized, one phenomenon which is rising is that also in agriculture, we're starting to see what are called in let's say more the epistemological field, black swans. So this means that there is a large scale unexpected event happens because you've been specializing towards preventing a specific class of diseases from happening. So what do you think are ways in which you can apply proactive techniques that are able also to, in some sense, prevent the unexpected? Do you think this is possible, or do you think this is a limitation of your system which is acceptable?
Yes, sure, we are normally we are in a globalized world, and this is true, especially in the disease. We are similarity between different ecosystems, and also we have different difference between each ecosystem. The ecosystem here is not the same in Australia. They have much higher temperature and less humidity than here in Europe. And this reflects the ecosystem to create. If research show, especially in the organic fields, that if the original ecosystem is created correctly, so based on the environment, the capability to respond quickly also to unexpected disease are very rapidly, and this ecosystem can respond, but must be complete in the sense. Sometimes the use of preceding techniques have a long tail also on the creation of perfect organic ecosystems.
Okay,
sorry.
Thank you. I see they have
Can I bring an example just to say that we are not talking also about abstract things, but about the real issue. How many of you are familiar with Xylella, an epidemic in the southeast of Italy? Okay, so this is a real thing, and we all fail to prevent Xylella. And
also to react.
Yes, but we are failing to react because we are putting our effort to prevent the disease. And we are not thinking about strategies to eradication of the infected plants and strategies to cure these plants. Because we are in a system that is every day more proactive.
So, in some sense, your argument is that the case of Xylella, which is a bacterium that infected olive trees in Puglia, especially, so in the southeast of Italy. And this was a bacterium that was common to the region of the North Africa, okay? And olive trees that were there were bred and selected to be resistant to Xylella, because of course they knew this bacterium was in the environment. While on the other hand, to maximize the yield of the olive trees in Puglia, we happened to select olive trees which were not resistant to Xylella, but were resistant to bacteriums that we had in Puglia. When the bacterium crossed, we had a systemic problem.
Yeah. So this is the consequences of the failure of prevention.
I just wanted to give the full picture. Yes, yeah. Please.
I want to answer just one aspect of your question. And so, in this year, after the event of this kind of thing, you can see that there aren't a solution to Xylella. So, the question is, if you have put more money in studying and to solve this Xylella, okay, maybe it will not have been, maybe, okay, don't know the correct value. Destroyed, because also now that is more than 5 years after Xylella, that money are being used to study Xylella, we don't have a solution. So in this case, I don't think that putting more money in a reactive approach would have solved the problem.
Yes, but can I reply? Yeah, I have a paper, a document that's just explain how we can efficiently eradicate the infected plants with our technologies. So monitoring with UAVs, satellite imagery, and this could be done
So
when the infection was weak.
Yes, but your solution, if I am not wrong, it's remove the plants.
Of course.
Okay, but what if you remove the plants now? Okay, it's the current solution. We remove like 2, 3, 4, 5 fields of near all the olive tree in Puglia.
No.
This is at this point your consequence of this is remove cause a food crisis because you don't have olive oil.
No.
But to respond to this, the problem is that you are thinking now. You put all your money into a pre-active system, you failed, and then now the disease has spread uncontrollably. Our approach would be to invest that money into more precise monitoring system so that we can intersect the problem at its first stages and we don't have to kill thousands of trees, we just remove the ones that are actually infected.
Okay.
Before
thank
it
you.
can spread.
I would like you to react, but before you react, give context to the whole class about this. You are looking now, they're having a discussion about what happens when a problem goes from the realm of something which is prevention to the realm of something that is cure. You understand that now we are using the case of agriculture, but this is not just about agriculture. You could see this as a mitigation of a technical problem in a system of whatever, cloud infrastructure, a security breach. You can see this in economic system, in finance. You can see this in many different fields. So take this discussion of agriculture as one test case of something which is abstract enough from you that you can reason about what are the impacts also in your field. Please.
Yeah. I just want to make a consideration to this. In fact, if you think about this problem, okay, the proactive measures does not work, of course, but also the reactive measures. This kind of approach is just eradicate trees, okay, and so I mean the same thing that I said before. And so if you use more money for a reactive approach, they will be used to study this Xylella to try to make some solution and things like that. But the thing about this thing, if we obtain a solution for this kind of thing for Xylella, do you think that in 2020 or later we will use this as a proactive approach? Or we remind every year waiting, okay, let's see if Xylella appear again, and then we use a reactive approach.
Well, that is linked with the problem of diseases evolving. So if you find a cure for Xylella now, and you apply it maybe in the next 5 years, then Xylella changes. And you have to find another one to counteract this change. If you only use it reactively, then when Xylella happens and you have the problem, you kill all of the problem. And it has no chance to evolve. It's just dead.
And you have no trees.
Yeah, but I think you don't understand the problem.
Do we have trees now?
The problem.
With a proactive approach? No, we don't.
I mean, imagine. So the study of also the proactive and then the reactive field is to try to make a solution based, in our case, on laboratories. In your case, then the problem happened. But the thing is that when we find a solution, what do you think that we will do? Always a reactive approach. So okay, we have a solution of Xylella. Let's see if in the next 100 years Xylella appear again and they destroy.
Well, the problem is it will appear again in another form, in another epidemic. So it's not Xylella, it's another name.
You can try to prevent it, you can try to see how it goes
no, but
in labs.
I think we have shown a very nice graph that says that if you try to combat a pathogen, let me talk. If you try to combat a pathogen, then nature will create a system that the pathogen evolves in another pathogen.
Can't we just create the network?
So I want to answer you.
Easy.
The network.
Yeah.
I want to make a question to you.
You can do
Okay,
it.
sorry,
It's what is
just
done.
one thing. I think, so now I don't see any team as able to strongly convince me, but I think also the whole audience, about one clear advantage. I see this as starting to be a bit of a circular argument. So, I would ask this, because we need to also go into a break. Do we have a question from the audience to the reactive team? Because so far we've been reading about them, but I think they also deserve a bit of torturing. Georgia.
So it's also a little bit related to this because it's about the resistance of bacteria to antibiotics. So you mentioned the super bugs or whatever. Which approach created the super bugs? The proactive or reactive?
Proactive approach. They are created because the antibacteria is always in the system. So their environment is full of antibacteria and they evolve to better live in this environment, so they develop immunities. If the antibacteria are not in the environment, there is no pressure, no evolutionary pressure to evolve these immunities, because it's like you're not better if you're combating a problem that doesn't exist.
Okay.
I don't know if I explained myself, but
So this problem appeared in the last years only after the
Yes.
proactive approach was introduced?
yes.
Okay. Can we have, yeah.
You have an answer to this?
Yes, I don't agree with this a completely proactive problems. Instead, if you think when you take an antibiotic, normally you have some kind of problems like
Side effect.
And after probably the small part of bacteria inside you that resist at this point is transmitted to another person if you or remain inside you, and they need an example for the weeds, they need this type of resistant plants or bacteria need 50-20 generation to came alive, so like 4% of the entire seed population.
Okay, I just think one more thing. You should also consider that when you have a pathogen, it's not that you kill it completely with the antibiotic. You also have an immune system, which helps the end
But
with the infection. Okay.
But something remain inside.
Yeah.
And so this, and you take as a reactive measures the antibiotics, not proactive measures.
Actually, I was also thinking like that because in humans also as well, we usually don't have a.
The proactive version was a little bit exaggerated.
Can I finish? Sorry.
Yeah.
Thanks. So when you take antibiotics as a human because you're sick and so you have to take it, and then afterwards this resistance is developing.
So, can I respond?
I remind you of one thing, however, which is a fact globally, but then I think we need to go to a break. Antibiotic resistance doesn't happen because of a reactive use of antibiotics. Because the problem is when you have systems which are very strong, sometimes they're applied independently from the cause. So you have a cough, they give you antibiotics. Of course the cough goes away, but does it go away because after 7 days it would have been going away anyway? Or does it go away because you got the antibiotic? So this, and you are living in an area of Italy right now where, especially in the human part, even though now we're focusing on agriculture, so it's a different topic, but in the human health, there is a lot of attention towards this. But if you go about, looking about statistics of overprescription of antibiotics in the US, for example, it's a different story. They're used as a much stronger dosage and for many more classes of problems than we have in Italy. Also because these are medical products that need to be sold. And somebody is making money out of this.
But how can a bacteria become resistant to antibiotics if you are using antibiotics but you don't have the bacteria?
Because you are still bombing everything. So what is left there is going to be resistant. So you always have a minimum level of pathogens in your system. You're bombing everything, But in the meantime, you're still selecting those pathogens. So eventually, when those pathogens will proliferate and you put the antibacterial, they will not go away. This is the problem.
Can I also add one thing to this? So I don't know if you know how bacteria DNA works. Bacteria have two types of DNA. They have the chromosoid that mainly are the things as humans chromosoids, and they have what are called plasmoids, which are small circles of DNA that are free to roam around the cell. And these are the ones containing all the information about the antibacterial resistance. And this chromosoid can be passed just with touch, or there are special bacteria that can harvest plasmoids from dead cells. So the spread of this immunity is much, much quicker than just the bacteria duplicating and growing. It can spread in between species because those plasmoids are almost universal between bacteria.
Okay, thank you. I think we need to go into a break.
Yes.
So let's have a break of 10 minutes.
We see here at 16. Okay, thank you.
Okay.
Guys, seated, thanks. Now we have other 20 minutes discussion, and then we'll have the final conclusions, and we will cast the vote. Just a parenthesis, while the two teams are discussing the strategy for the next 20 minutes, because they need to we will have a pizza get-together tomorrow. We still need to decide the place because we collected the people who wants to come from INE Basics. We need to know roughly how many of you would like to come. Just raise your hand, we will count you. Because we are, I think, quite a number, given the people
So we are a big number, so we need to know how many you are, so that we can book a place.
Yes,
because
there will be
it's hard to find a place.
maybe a table, maybe a double table, because if we are too much. So no, I mean, you are not obliged to come. If only you feel you would like to, and you feel like you want to come.
Tomorrow, 8:30, place to be determined.
Place
but
to be
somewhere
determined.
in downtown.
Yes, downtown could be Pedavena, could be Glotta, something. Because we are a huge number. So just raise your hands. Who is willing to come?
Una ventina.
Sì, 15-18. Ok, thank you. Please, let's go.
Okay. No. Let's go back to the battle. Before giving word to you, can I just ask you, what would be your point?
It's about the scalability.
Okay, scalability. It's interesting. From the audience, did you elaborate any questions you want to give out now? Yes? What would be your point about? Actually,
about cost and expenses.
Cost. Okay, and what about you?
The evolution of the document.
Okay, so what about you?
Also GMOs.
GMO. Okay, so you would...
Biodiversity.
Biodiversity. Okay, so I will start from scalability, move to biodiversity. The bacteria, we discussed it a lot already, so I will not go back to this. Just to see some different topics. So let's start from this point of scalability. Yeah, please.
One of what I think it's an issue of a reactive approach. It's how you scale the ICT technology you think to use. So, an example, you say the electric wires on the fields. Yes, the coaxial open-ended wire, if I remember correctly. And the problem if you need to set up and after at the end, before you harvest the crop, you need to obviously this cable needed to be came back, and this is a huge cost, especially if you think a reality like Australia, where you have it's not convenient to take to the farming to the tractor side.
Okay. Well, the coaxial probes.
Okay, sorry, there's one thing. I would, since you were talking about costs, right? You had a point on costs.
GMO.
You had a point on costs. Could you follow up to this? Do you have a way to connect to this? Or?
It's more related to his business, so.
Okay. No, right. So please answer for now. Yeah.
Coaxial probes are not wires. Yes, you use a wire, but it's an antenna, and then you can transmit the data over wireless. So there is not a problem of long cables along the field. For the scalability, okay, small farmers can use, for example, an app like the one I put on the slide, which has a very low cost. While more bigger farmers can use wireless sensor network, distributed sensing, collect data into a cloud, elaborate, and so on. So the scalability is not really a problem for our active approach.
Okay, thank you. I will follow up with one question to both teams, which is the following. So, in both cases, you are arguing for technologies, okay? So you are talking about how technologies fit into your vision of either proactive agriculture or reactive agriculture. And you are nailing down some big trends that are now in the broader discussion of ICT in general. Because you're talking about sensor networks, you're talking about computer vision, you're talking about GPS imaging, and so on. If you can, I will give you this challenge. Can you think of one technology which is now very much emergent, so it's not yet something that everyone is talking about? It's something which is still very early in the developments that may be fitting into your vision. I don't have anything in mind, okay? This is not a leading question. I'm just asking you openly. Can you think of something which is not here yet, but sometime in the future, 10, 15 years from now, could be a breakthrough for your vision? So, can you sell us a ticket to a science fiction movie which is interesting in this sense?
They want to start.
Do you have an idea?
Yes, like I was saying before, nanotechnologies, because there are biosensors, but also quantum radars, which can detect, for example, the type and other type of diseases inside our plant.
So how do these things work? What are they
You
about?
transmit a quantum over the air, and when you receive back it, you can, for example, know the material of the host, not only if the host is there, but as I was saying, the nature, the color, and other interesting things, and I think also the disease.
So I try to trivialize it extremely. This is a super sensor in some sense.
Yes.
A super radar.
Yes.
Super radar. Okay.
But they are trying to developing nowadays. They are not here, but in the future it's a possibility.
Right. Do you have also something?
Yes, but for example, a technology that started to emerge now, it's the intelligent machines. So, an example, John Deere now, near all the harvesters they produce are inserted inside a sensors that measure the production on less than 1 meters or 50 centimeters. And these data are after sent to John Deere's and obviously to the farmers. And now John Deere's with this data and with this type of sensor that analyze also the not only the yield but a series of other parameters, try to build models for how the disease spreads and how to prevent them.
Okay, so in some sense, specific hyper-localized models,
yes,
of disease spreading and disease diffusion in a certain part of the world. Could you tell me again the name of this company? Which is
John Deere.
John Deere.
Sorry?
John Deere.
Never heard of it.
You see probably.
D-E-E-R-E. I trattori verdi.
Guys, the only thing I know
You're
about
from
agricultural
Venice, that's
companies
right.
is Scala in Ancona, we sell but that's it. Okay. Okay.
They're very nice.
I will investigate. But this
I think also New Holland probably.
Okay, New Holland. This is Fiat.
Thank you.
Made something of this.
Okay. So we had the point of scalability. Now you had a point on biodiversity. Do you want to make it?
Well, yeah, I want to ask them how they plan to deal with biodiversity with a proactive system, because using a proactive systems means that you are killing microbes, insects, everything that can be a problem even before it becomes a problem.
Okay, let me try to rephrase this into another perspective. Still about biodiversity. When we started doing industrial agriculture after the 30s, this was started by the work of Fritz Haber, who discovered the fixation of nitrogen and the idea that we can have fertilizers. Okay, this is what started industrial level agriculture. When this happened, we started cultivating hybrids. Okay, so specific seeds, which are hybrids of two different species that maximize the yield of the crop and they're resistant to some diseases. This has been a proactive measure to increase the yield and at the same time increase the resistance of the crop. But so far this has created a problem where now all the crops variety that we used to have before we started to select these hybrids, first, are just conserved in seed banks, and we don't know if the amount of seeds that we have in the banks is enough to bootstrap the subspecies again. And second, the companies that produce the seeds for the cultivated varieties are very few. And they are the risk of becoming a monopoly. How do you think we can break this vicious circle? So, this is a nasty question for you, but I want to give a nasty question for them as well. The nasty question for you is this. Sorry, give me just a second, because I had it here. No, okay, start from this and then we'll follow up.
You have a comment related to this question?
Yeah, the hybrid seeds, the first generation of hybrid seeds have a great production, while the following generations have a lower production than the original one. So you have even a higher cost because you have to invest every production in seeds.
You have diminishing returns, so-called. Yes, I have the nasty question for you as well. So when we abandon micro-scale architecture, agriculture, okay, and also reactive agriculture, we had very good reasons to do so, because we needed to sustain the growth of population in the planet. So in some sense, this is connected to the idea of scalability. Now, your point is basically saying, now we are mature enough to go back to this system. But I would like to ask you one good reason why. Because I still haven't fully grasped this, and please, the reason should not just be technology. Try to be specific. One good reason why we are mature enough to go back to this type of production, which preserves biodiversity and has a lot of, makes more tasty fruit and has a lot of benefits. So, nasty questions for both, okay?
So, about it's true here, especially in Europe, in the Europe context, there is a very small number of companies that make the seeds, and a very small number of agriculture trade the seed themselves. This is not so true in some states like in Australia. In Australia it's very common, and there is a company that produces the machine with a cost that's like a machine for the seed treatments is like 10,000 euros of cost, more or less. and this agriculture, they own a very large number of yard of soils. They a part of the previous year's crop are treated, and the next years are planted again. So they reduce the cost at the end.
No, I'm trying to, sorry, thank you, but I'm trying to have a different answer from you. I'm trying to ask you how we can now have proactive agriculture which preserves biodiversity.
Okay.
How do we break the vicious circle of monopoly? How do we get rid of Monsanto?
Yes. So, or you recycle a part of, so you try, the first years you try to scale the production, so you have, so an example, you have 5 on the seed vault. After you can plant, you need a couple of years to recover from this. And so, like the first year, the 0.5% of the production is destined to replantings. After the second years, and so you have like an exponential factor at this point, and so you recover this biodiversity. The problem that probably you think, I think you ask me, it's how it's possible without the bank seed recovery this production. There is some farmers that made this it's low scale productions. If we want, we need after to push on the organics agricultures and recover and start to scale this small scale production. Obviously, for the farmers, as now, it's more convenient to have more yield possibles. So we need to do without OGM, probably mixing, and this mixing species to augment the yield. But this, it's like, I think it's a natural thing. So if you think with this system of mixing, with the Roma we have a production of 1 on 2. So for 1 seed plant, we have 2 seed results. Now we have a production of 1 to 22.
Okay.
And probably, I think if we are at the with the Roman certifier, I probably we are 3, 4, 5 in this
Right.
class.
I will not follow up to both answers, but okay. What about you?
The main reason is because now farmers are more informed and more professional than the past. For example, I followed a course of 700 hours, which is not mandatory, but it's really recommended if you want to become an agricultural entrepreneur in Trentino. And this can be worldwide because now information is can be reached by everyone through internet, simply. And so farmers are more are able to find an answer, a reactive answer to the problems that are presented to them.
And another reason is because the market is shifting its attention, and now customers are much more willing maybe to even spend a little bit more if they know that the product is preserving the environment and is favoring biodiversity.
Okay, thank you. By the way, this is a good point to think about where are my friends of the next battle. Over there. Also to think about the next battle, okay? All right, so time.
We have another meeting for another question. I would like to stimulate the entrepreneurial part of the guys. So your last question, then we close, conclusions, and then we cast the vote, okay? So we help him making his own business on agriculture.
Okay, I'm going into agriculture, and I'm going into it because of profit. And your reactive method is saying that me seeing something, maybe a disease, before I react to it? What if the period with which I'm going to see it, in reacting to it, by the time I finish reacting, all the crops have been destroyed. I can't do anything about it again. That means I've invested cost in production, plowing the land and everything. At the end of it all, cost in trying to prevent the disease, which couldn't yield any fruit, and then at the end of it all, getting nothing. So what do you think about it? As someone who wants to go into agriculture for profit, I can't farm a whole year and lose everything. So what do you think about it? You are going to lose everything at the end of it all. Meanwhile, you could have prevented this from the very beginning. That's my question.
Okay. So a sort of consultancy for him, please.
So my answer is you cannot try to change a whole system alone. If you live in a whole system which is proactive, it's not feasible to think that only you are going to adopt a 100% reactive system. So what we are encouraging is a shift of all the system towards a more reactive approach. And this is because you are only considering your cost in your money, but we try to look at the further picture and look at the earth and what we are leaving to our grandchildren. So yes, you are spending less and you have less risks, but you are using up a buffer of resources that are in the planet, and then sooner or later are gonna finish, and then you're not gonna be able to do anything. So we try to stop the destruction of the earth before it happens.
But in any case, when you find out that the disease is there, or this is the pathogen that is affecting you are still going to use the chemicals in preventing them. So what are you trying to say? At the end of it all, you are still going to use them.
If you have the problem,
Yes, yes, if you have the problem, and what you are supposed to prevent in the initial stage, you didn't prevent, and then it ends up hunting you in the future, losing everything. What I
Yes, that's the trade-off. It's between, if you fail with a reactive system, you fail miserably, like with Xylella. If you fail with a reactive system, if you have a good reactive system in place, you discover early that you failed and you can minimize your losses.
Okay.
You are maybe more likely to fail, but your failure is going to be of a lesser magnitude.
Okay, I think there was a word point problem. You said reactive twice. The first was wrong.
I'm sorry.
Okay, I think we need to draw conclusions because we're very late.
1 minute, or 1 minute, well, your conclusion was already here, I think. So 1 minute for you, 1 minute for you, and then...
Okay, in the meantime, while you think about, are you already ready for conclusions? Or should I fill something? Okay, all right. So I will fill with something. Of course, this is my first time being here for a battle, because before I've been in the IBICT. But I would like to highlight two things. So, you should be looking also, just as a meta point, at what I call the identity building. So, once you are taking a position, each of these positions has a connotation to it. It refers to a mindset that you need to have for this vision to go into practice. So the proactive approach goes into the mindset that we can control things, right? And we can foresee the future. The reactive approach instead goes on the mindset that we can be quick, we can be fast. So after you vote, because I don't want to bias too much, I want to show you two very small things in which they, in the discussion, probably unconsciously, adopted the vision that they were saying in how they behave. Okay?
Can you sum up in 30 seconds and 30 seconds, because we are hurrying up a lot? You start or do you start?
Let me start.
10 seconds
Okay.
and we'll start.
Who made the presentation first? You did. So you start now and they... Okay. 30 seconds.
Guys, to recap, when you fail due to prevention, so with a proactive approach, the damage to your failure is unsustainable, not only for you, but also for the environment. So let's think about biodiversity, let's think about climate change, and all the things we talked before. We think that the time are mature to shift versus a reactive approach. So we maybe lose something now, but we'll earn much later. Okay? Try to think about the new technologies that are evolving. Nanotechnologies, UAV, remote sensing. All these technologies are helping us to monitoring, detecting, diagnosing, and cure the problem. Okay? While instead, with a proactive approach, you are not sure that your system will work. Okay? Okay.
1 minute only, because the new class needs to start.
So, I have a question for you. And my question is, do you want to be a person who solves the problems only when problems appear? Or do you want to be a person that think of the problem and think of his plan and plan his life before?
Be quick. Last is a K.
YX2EMYQ. All not capital letters. The two teams cannot cast their vote. Hurry up. Who has done? Okay. Who hasn't? Okay, try to close.
Il prossimo lunedì, vero?
Wow. Who hasn't?
I think it's still.
Please.
This is
Try to be quick. Okay, are you right? Done? Not yet. Who is missing? A couple. So well.
Okay, but I think it's very said.
So.
Okay, so 77% against 22, reactive wins. Guys, before going away, you will see each other next Monday, but I want to highlight one thing. Think about who had the goal, so they were trying to sell you a movie, both of them. Think of who had the goal of selling you the ticket of the movie you were already watching. Which one is the trend which is currently active? And were you able to buy the ticket, or did you change your mind?